Hello friends, today we shall discuss the concept of offsets and the method by which offsets are taken. For that, let us visualize a daily situation where workmen assemble in a factory and supervisor meets them and tells them about their today's work location and the work to be done by them. Setting offset is something similar to this. Today we shall discuss CNC turning offsets only. In CNC turning, the workpiece is held firmly as per pre-designed configuration and rotated at required RPM, which may vary as desired. Tools are moved along the workpiece as per desired profile, required number of times. This is executed exactly as instructed to the machine with a set of sequential instructions called a CNC program. The basis of tool movement is two-dimensional coordinate geometry. Programming is done based on component drawing. In CNC turning, there are two axes, namely X, the perpendicular one, and Z, the parallel one, with respect to the axis of rotation of the spindle, also the axis of the workpiece. These two axes intersect each other at a point called the origin. Generally, the intersection point of finished front face of the workpiece and the spindle axis is considered as a suitable choice of origin, which is used to describe the component profile. There are two numbers associated with every point on this profile, which are the distances of the point with respect to origin measured along these two directions. These numbers are called coordinates. Origin and coordinates together form the user coordinate system, namely the UCS. Thus, complete component description in terms of UCS appears like the drawing. Coordinate values depend on the choice of the origin. So, changing origin will change all the coordinates. Since we do machining of thousands of varieties of parts, we cannot relate origin to a particular UCS related to a specific job. Hence, the coordinate system and the origin with reference to which the machine works has to be independent of the component being processed. This system is called the machine coordinate system, that is MCS. All the movements taking place in the machine are internally calculated with reference to this MCS origin. The machine takes care of all movements required for a profile defined in a particular UCS suitable to a component and converts this information to MCS. We need many tools to machine a workpiece. These tools are clamped onto the turret tool disc. The cutting edge of each tool comes at different distance in X as well as Z direction with reference to the turret tool disc. When each tool is moved to UCS origin, the turret tool disc is at different position with reference to the MCS. The activity of telling about this turret tool disc position to the controller of the machine is called taking geometry offsets. These geometry offsets are entered in the geometry offset page of the machine. Taking correct geometry offsets is very important. Otherwise, we may get a wrong job or have to face an accident on the machine. Procedure of taking offsets. Select the manual mode MDI. Call the OD turning and facing tool. Give command to rotate the spindle. Start the spindle. Switch to jog mode. If the spindle stops, start it again by using spindle revolution button on the control panel. Bring the tool near to the workpiece. Switch to manual mode. If the spindle stops, start it again by using manual pulse generator wheel MPG, also called electronic hand wheel. Move the tool so that it gently touches near the maximum diameter at front face of the workpiece. Move the tool in X plus direction to clear the workpiece, first switching MPG to X axis. Move the tool in Z minus direction by a small amount, first switching MPG to Z axis. Switch MPG to X axis and take a small cut from front face of the component in X minus direction. Repeat this until the face is nearly cleaned. Without touching MPG switch, go to offset, geometry offset and set the current tool Z offset to 0. Switch MPG to Z axis and clear the tool from workpiece front face. Switch MPG to X axis and move the tool in X plus direction to clear the workpiece. Start the spindle. Switch MPG to Z axis and move the tool past the front face of the workpiece in Z minus direction. Switch MPG to X axis and move the tool along X minus axis to lightly plunge into the workpiece. Switch MPG to Z axis and move the tool slowly along Z plus direction to clear the front face of the workpiece, taking a small cut along Z plus direction. Switch MPG to X axis and move the tool a little along X minus direction so that it shall take a small cut along the diameter of the workpiece. Switch MPG to Z axis and take a cut on the OD for a sufficient length, say 10 to 12 mm, so that correct measurement of diameter by vernier or micrometer is possible. Repeat taking cuts on diameter until the workpiece diameter is cleaned. Stop the spindle. Measure the diameter of the workpiece. Without touching MPG, go to offset, geometry offset page and enter the measured value of diameter of the workpiece. This completes procedure for taking offsets for first tool. Index the turret for the next tool by first moving the turret sufficiently away from the workpiece so that the current tool as well as all other tools do not hit the workpiece while indexing. Switch to jog mode. Take a small piece of paper. Bring the tool near to the workpiece, taking sufficient care so that the tool does not hit the workpiece. Switch to manual mode. Switch MPG to Z axis. Move tool slowly in Z minus direction until it comes nearer to the front face of the workpiece, say around 0.5 to 1 mm away. The MPG is on 10 micron mode. Now insert the piece of paper in between the tool and the front face of the workpiece. Now slowly move the tool in Z minus direction while constantly moving the piece of paper along X axis. The paper will be difficult to move and eventually shall not move. When the paper stops moving, select offset, geometry offset and set the Z geometry offset of the tool to 0. Repeat the above steps to take X offset of this tool also. Warning: sometimes drilling and boring is also done on CNC lathe. X offsets of boring tools cannot be taken before drilling. If you forget this and start executing boring program, the program will advance with the offset value in the memory taken for some earlier processed setup. There will be an incorrect offset which will create an accident as well as wrong jobs. Do not forget to take boring tools offset in X after drilling by interrupting the program. While taking offsets, please ensure that present bore size is greater than d mean of the current tool. Otherwise, the boring bar while entering the bore will touch from rear side also and the insert corner shall break. Taking X offset of drills. While drilling, the drill has to align with the spindle axis. The X offset value of drills is a distance between two fixed points, so it is a fixed value for a machine. Taking X offsets of boring bars. The procedure is similar to an external tool with the difference that now cuts are taken along X plus and relieving is done along X minus direction. Now to sum up, let us go back to our example of various workmen assembling in a workshop and supervisor assigning them various duties. Here, assembling of various people to workshop is equivalent to taking geometry offsets, whereas supervisor telling them their duty is equivalent to running a CNC program.